Okay, so I'm going to fill in the rest of the notes that we took regarding translating exponential functions. So the parent function of a regular exponential function, okay, the regular function is in this form, where a is the starting point, b is the growth or decay factor, and then x, if this was a word problem, would refer to the time. So this is just the normal parent function for every exponential function. So what we're going to do is we're going to kind of use a format we're familiar with and we've used with absolute value functions, we've used it with quadratic functions, we've used it with radical functions. Now we're going to use the same kind of notation with exponential functions, and this will help us to translate those functions. So we have our normal function here. We're going to add up here in our exponent an h, and then down here below is our k. So I want you to pay close attention to these because they're going to work the same way that they worked when we were doing other functions. Okay, so that's what I'm going to do down here, just kind of remind you of what happens. So the a value is a starting point. If the a value is positive, it will curve above the x-axis. If it's a negative a value, it's going to curve below the x-axis. So if a was positive, it would be like this or like this. If a was negative, it would be like this or this. Okay? All right. It's just a good little, whoops, sorry. That's a good little reminder. Okay, so let's look at the h and the k, which is really what we want to pay attention to because most of our problems are going to involve an h and a k. The normal function involves a minus h. So if the value of h became positive, okay, if this became a plus h, then that means that the value of h originally was a negative, okay? So we would have to move to the left. If h stayed as a minus h, then that means that the value of h was positive, so we would move to the right. The only way to make this become a positive h is for the value of h to be a negative, because minus a negative value would turn into a plus. Okay? It's kind of the opposite of what you would expect. And then the k value is the vertical movement or the vertical translation. So h is the horizontal translation. And now the k is the vertical translations. And they work exactly like normal y values work. If it's a positive k, we go up. If it's a negative k, we go down. Okay? So I'm going to do some examples with these, and this will kind of get you started a little bit. Okay, so it says graph, and example number 1 says y equals negative 3 to the x power. Okay? This is almost exactly like a regular function. Okay? So what we're going to do is we're going to kind of ignore for now this negative, and we're going to find the points that would allow us to graph the parent function. Okay? So that's what we're going to do here. We're going to pretend we're graphing this function instead. Okay? And then we're going to translate this based upon what happens with the values. Okay? All right, so let's plug in some values here. Let's do some positive and some negative. So let's start with negative. Start with negative 1. 3 to the negative first power is going to give you the fraction 1/3. And you know the moment that you see a fraction, this is rapidly getting closer and closer to an asymptote. Okay? Then we have 3 to the 0 value, which would be a 1. Anything to the 0 value is 1. And then 3 to the first power is 3. 3 to the second power is 9. So that gives us some points that we could have plot. But what we are told, what we originally have, and what we're going to translate, is that these values originally might have been above the x-axis. They're going to drop below. Okay, these are all going to change to below the x-axis. So negative 1 1/3 would be somewhere up here. Okay, so we're going to, I'm sorry, negative 1 1/3 would be somewhere up here. It's going to drop below the x-axis to negative 1/3. So it's going to be roughly right there. Okay, all of these points are going to change. The y values right here are going to all change to a negative. Okay, that's how these are going to translate. All right, so 0 1 0 1 would be up here. So we're going to change it to 0 negative 1 right there. I'm just changing the color of these. And then 1 3 would be somewhere up here. It's going to change to 1 negative 3. And then 2 9 obviously would be somewhere way up here. 2 negative 9 is going to drop below. So 1 2 3 4 5 6 7 8 negative 9. And then you can go ahead and kind of sketch in the graph there. Okay? And that gives you an idea or a general sketch of what it would look like. So essentially, I took the points in my parent function, and all I did was make the y value negative, and that made it flip below the x-axis. Okay. I'm going to pause the video, and then I'll come back and do the two other examples in a moment.